representation of functions by power series. Here we want to be able to use the idea of a geometric series to be able to represent a function based on a power series formation. And then from there we can find the so-called interval of convergence of that power series. The basic function that we consider here is the function f of x equals to 1 over 1 minus x. By using the geometric series as defined, the summation a times r to the n, where r is the ratio, this is equal to, if it's convergent, a divided by 1 minus r, where r is between 0 and 1, that is the absolute value of r. So here, in other words, if we represent a equal to 1, r is equal to x, then we get that basic function 1 over 1 minus x, which then can be written as the summation of x to the n. So if that be the case, then let's just start with the problems and see if we can work our way through it. So here, find a power series for the function centered at C and determine the interval of convergence of this particular function. So we take the function f of x, and if it's centered at C, that means that we got to have written in the form x minus 1. So this is 1 all over 3 minus x, and I'm going to say in parentheses x minus 1, but we just can't put a number in without having its direct opposite to counteract it so that we have the original form. So I've just added to this x a sophisticated a 0, and here I want to have left x minus 1 in parentheses. So I'm going to take out the positive guy. We distribute that to that negative 1 on the outside. So this is 1 over 3 minus x minus 1, and then this is minus 1 here, with this 1 coming out. So this is 1 all over 3 minus 1 is 2 minus parentheses x minus 1. Now the form that we need is this, 1 over 1 minus x. That's all I know. That I know that this is the summation as n goes from 0 to infinity of x to the n. That's all I have in my head. I'm trying to build that form. So to build it, this 1 is significant. That 1 up top is not, because that number there, whatever it is, can be multiplied in front of the summation. But this 1 is important. That negative is important. This term here is important. So I'm going to build this form. I have to deal with this 2. So this is 1 over 2 times the expression 1 minus x minus 1 divided by 2. Do you see that? And so this is 1/2 times 1 over this is 1 minus x minus 1 all over 2. This is of the form. What's in the bracket? See how we did that? This is 2 times 1 is 2. Then 2 times this term divided by 2. The 2's cancel. You have left just negative parentheses x minus 1. So we have not harmed the expression. So this is 1/2. Now I'm going to use this form here to map it up, times the summation as n goes from 0 to infinity, and this is x minus 1 divided by 2 to the nth power. And it doesn't matter if you want to write this, you can pour this 2 in there. This is the summation as n goes from 0 to infinity, x minus 1 to the n to the nth power. This is all over. This is 2n plus 1. 2 to the n plus 1. So that's the power series. Now find the interval of convergence. We apply the ratio test, you recall. The limit as n goes to infinity of the absolute value. It doesn't matter if you want to use this or this guy right here. I'm going to use this, but for most of them, I'm going to use this when I use the ratio test. So this is x minus 1 to the n plus 1 over 2 to the n plus 2. This is divided by x minus 1 to the nth and that's divided by 2 to the n plus 1 is equal to the limit as n goes to infinity. This is times the limit of the absolute value, excuse me. This is x minus 1 to the n times x minus 1 times 2 to the n plus 1. This is divided by, this is 2 to the n plus 1 times the 2, that 2n, 2 to the n plus 2, and then this is times x minus 1 to the n. You can see the terms that cancels out. So this is the limit as n goes to infinity here of the absolute value of x minus 1 over 2. Notice here that we don't have any n factors, so this is the ratio test. For the ratio test to be absolutely convergent, we have to have less than 1. We can do that because there's no n factor to determine the limit. So the limit, this becomes a constant. The limit of a constant is a constant, so all we have left is, this implies that this is the absolute value of x minus 1 less than 2. Just multiply that 2 to both sides. This implies that we have negative 2 less than x minus 1 is less than 2. That is to say, add 1 throughout. We get negative 2 plus 1 is negative 1. It's less than x is less than 2 plus 1, 3. So the interval of convergence is from negative 1 to 3. Okay. Alrighty. So two things that you wanted: the interval of convergence and then also the power series. Let's look at the next one. All right. Well, I like this guy. When they're centered at 0, it's almost like minimum work. All right. So this is 1 over 1 minus 3x. Again, here's the only thing that I know. I don't know too much, but that I know. I share with you. All I have is 1 over 1 minus x. This is all I'm using for this entire section. Is equal to the summation as n goes from 0 to infinity of x to the n. It's just the geometric series simplified, if you will. So in using that, so this is equal to, I can go right to it. Summation as n goes from 0 to infinity of, this says 1 over 1 minus x. If everything is in the correct form, this x term goes there. Well, this x term here is 3x. So I write 3x to the nth power. You're done. That's the power series. You can say, or I won't write it like, I won't keep it like that, but you can write it like that if you want. It doesn't matter. You can write this as 3 to the n times x to the n. I like this form here. So apply the ratio test. This is the limit as n goes to infinity of the absolute value of 3x. And since it was centered at 0, that helped us out, right? So there was no parentheses x minus something. This is to the n plus 1, and this is 3x to the n. This is the limit as n goes to infinity. This just becomes the 3x to the n cancels out. You have left up top 3x. So this is the limit of the absolute value of 3x. Here there's no n factor within the absolute value. So without loss of generality, we can restrict this to 1, less than 1, based on the ratio test for convergence. 3x becomes a constant in respect to n. So the limit of a constant is a constant. This implies that the absolute value of 3x is less than 1. That is, -1 less than 3x less than 1. And that gives us -1/3 less than x is less than 1/3. That is your interval of convergence, or -1/3, comma 1/3. What about this one? Oh boy, as a deacon at the church, if he gets to something that's a little bit challenging, he says, oh boy. Well, let's see, 5 over, I'm going to write this as -3 plus 2. X becomes, this is x minus the -3 is x plus 3, then minus 3. So this is 5 all over -3 plus 2 times x plus 3. This is the function or the series centered at c equal to -3. Now take the negative part out. So this is 2 times -3 is -6. So this is 5 all over -9 plus 2 times x plus 3. Well, you recall the form, purple, Piper. So the form again is 1 over 1 minus x. The function here can be written in terms of a power series representation. This is the standard form. So I want to build that. If you don't have it, you want to get it. Where do you get it? You look around. I don't see it. Okay, well, we have to make it work. I need a 1 here. You also need a negative there. We may get the negative from this -9. So this is 5 all over -9. Just factor out a 9 from my denominator. So this is 1 plus 2 times x plus 3 all over -9. So this is -5 over 9 times the bracket 1 all over 1 minus 2 times x plus 3 over 9. You can write this now. The inside is of the form here, right? Inside the bracket. So this is -5 over 9 times the summation as n goes from 0 to infinity. The negative is important because if it's not a negative, then it becomes an alternating series. And you'll see that in just a moment. So this is, you can write this as 2x plus 6 over 9. This is all raised to the nth power. Now, you can write this. I'm going to leave mine like this, but you can write this if you want to as, say, -5 times the summation as n goes from 0 to infinity of 2x plus 6 to the nth, and that's divided by r to the n plus 1. But I prefer this one. Now we need the the interval of convergence, it is safe to use what's happening inside of the summation, right? So irregardless of this factor right here, that's pretty cool. Because convergence is based on what the summation is summing, right? Not the multiplied factor on the outside. So we have the limit as n goes to infinity of the absolute value of 2x plus 6 over 9 to the n plus 1 divided by 2x plus 6 over 9 to the nth power. So after you do this for a while, you see what's happening. So this is the limit as n goes to infinity of the absolute value of 2x plus 6 over 9. This is less than 1. Again, there's no n factor there, so we can make the restriction applicable to the theorem for the ratio test for convergence. The limit of a constant is a constant, so this is the absolute value of 2x plus 6. Thinking about the 9 in my head, you read my thoughts. I better use that. And just multiply both sides by the 9, which is less than 1 times 9, just 9. So that is, we have negative 9 is less than 2x plus 6 is less than 9. So we subtract everything through by the 6 and then divide everything by the 2. So we get negative 15 less than 2x is less than 9 minus 6 is 3. Then divide everything by the 2. So we have negative 15 divided by 2 is less than x, and that's less than 3 all over 2. So you can write your interval of convergence as negative 15 over 2, comma 3 over 2. And they don't ask to check for the endpoint. So if they don't ask, I don't, submit willingly. Okay, now this is the last hardest problem. I think the other 2 problems, or 3 problems after this, kind of straightforward. We'll always have, a little bit extra time when we have a center equal to 2, or a center equal to a number other than 0. Let me say it like that. So this is, write the function. It's 3 over, this is negative 1 here, plus 2 times parentheses, this x minus 2 plus 2, right? We still want to conserve the energy, so we're just adding by 0, which is safe. So this is negative 1 plus 2 times x minus 2. Take the negative part out, which is this plus 2, if you will. Excuse me. We need this negative guy. I'm sorry. We take the extra. How about that? Out. So this is 2 times 2 is 4, plus 4, right? This guy. Oh my God. Okay, anyway. This is 3 over Dougie Fresh. Yeah, Dougie Fresh. So this is negative 1 plus 4. This is 3 plus 2 times x minus 2. Too much. Okay. So we can write this as 3 all over 3 times brackets 1 plus 2 times x minus 2 over 3. Now, it looks like it's the form, but it's not. The form is 1 over 1 minus x is equal to the summation as n goes from 0 to infinity of x to the n, right? So the 1 is here. That's good. The x term is there, but it's not minus. It's supposed to be a minus there. Let me give you this. Let me tell you this. If you have 1 over 1 plus x, then that's really 1 over 1 minus a negative x, which is the summation as n goes from 0 to infinity of negative x to the nth power. And do you want to see how we get alternating series? That this is the same thing as the summation as n goes from 0 to infinity of negative 1 to the n times x to the n. That negative x is negative 1 times x, right? So if it's negative x to the nth, this is negative 1 times x to the nth, and that's equal to negative 1 to the n times x to the n. So if you have something like this, I don't like that either. Sorry. That's fine. So this is a plus sign, so it's going to be alternating series. That's my point. So this, well, the 3 divided by 3 cancels out. This is 1 minus, see that? And this is 2x minus 4, and I'll just say that this is negative 3. Put the negative there. That's fine. So this is equal to the summation as n goes from 0 to infinity of, you can write it like this, negative. It's hard to put that negative in front of these terms here. Crap. 2x minus 4 over negative 3 to the n. And you can make this negative 3 as negative 1 to the n, so that comes out like this. I'm just redoing what I did up here. If you see that, you could just go from here and just write it. Negative 1 to the nth times 2x minus 4 over 3 to the nth. Okay? Now, what about the so-called interval of convergence? This is the power series. So the limit as n goes to infinity we apply the ratio test of the absolute value. No need to deal with the negative 1 to the n within the absolute value. So here we have 2x minus 4 over 3 to the n plus 1. This is divided by 2x minus 4 over 3 to the nth power. This is the limit as n goes to infinity. Now, you see how these terms cancel except the plus 1 value? So this is 2x minus 4 divided by 3, which is left, right? Just do it here, and then hopefully hereafter we don't have to put that in there, because you see what's happening. Maybe my video is there, my image. Well, maybe I'll put it up there. I don't know. But anyway, okay. Okay, sorry about that. Let's see. I was trying to make it funny. This is the limit of the absolute value of 2x minus 4 over 3. Here there's no n factor, so we can apply the result of convergence for the ratio test and say this is less than 1. The limit of a constant is a constant. So we have here the absolute value 2x minus 4 over 3 less than 1. By definition, this is negative 1 less than 2x minus 4 over 3 less than 1. Multiply everything by the 3. So this is negative 3 less than 2x minus 4 is less than 3. Add everything by the 4. So this implies that we have negative 3 plus 4. That's 1 less than 2x less than 3 plus 4 is 7. And this is now divided by the 2. And so we have 1/2 less than x is less than 7 over 2. That is, the interval of convergence is 1/2. Everything between 1/2 and 7/2. Okay. And that makes sense. And just make sure. That looks good to me. Oh. That's the interval. And you got the power series. Okay, now let's see if we can do this one now and not hurt ourselves. This is 3 over 4 plus 3x. So this is 3 all over 4 times brackets 1 plus 3x over 4. So this is 3 over 4 times the summation as n goes from 0 to infinity. It's plus sign, so it's alternating, negative 1 to the n. And this is times 3x over 4 to the nth. Now, a couple of ways you can do that. You can pull that 3 in there. You can pull that 4 in there. Best for me, I just leave it the way it is. I put here, or if you want to plug it in there, just to show you how it looks. Very messy, if you ask me. So this is 3 to the n plus 1 times x to the nth divided by 4 to the n plus 1. Right? So to find the interval of convergence for the ratio test, I use that guy right there. And I'm only going to consider that part, what's inside of the summation. You get the same result if you use that, but this is a little bit easier. So we apply here the ratio test. The limit is n goes to infinity of the absolute value. Now again, the negative 1 to the n is going to go out because of the absolute value. So we have 3x over 4 to the n plus 1 divided by 3x over 4 to the nth. Well, this is through simplification. I think you get it. The limit as n goes to infinity of the absolute value of 3x over 4. Again, there's no n factor, so we're safe to say this is less than 1. This implies the limit of a constant is a constant. So we have here the absolute value of 3x divided by 4 is less than 1, or you can just multiply by the 4. So this is less than 4. So that gives us negative 4 less than 3x less than 4. And that is to say that negative 4 over 3 is less than x, and that's less than 4/3. And this gives us our interval of convergence. Negative 4/3, comma 4/3. One more. Alrighty. So here, this is 2 over 1 minus x squared. We're done. This is 2 times the summation as n goes from 0 to infinity of, if this was x, you'll say this is x to the n. But this is x squared, so this is x squared to the n. And you can just write that as 2 times the summation as n goes from 0 to infinity of x to the 2n. So this is the power series. What about the interval of convergence? We apply the ratio test. This is the limit as n goes to infinity of the absolute value of x to the 2n, and we're adding a plus 1 term there. So this is 2n plus 2, which is really it's the plus 1 on the n all over x to the 2n. This is the limit as n goes to infinity of the absolute value of x squared. Here, this is less than 1. The limit of a constant is a constant, so what we have here is the absolute value of x squared less than 1. Ideally, we get the same interval for examining the absolute value of x less than 1. So we get negative 1 less than x less than 1. So our interval is from negative 1 to 1. Right? Well, that'll do it. Thank you.